So today is the second day on 3.1. And what we did yesterday was we'd have two functions like f of x and g of x, and you would just simply add them together. So let's say or subtract them or multiply them or divide them. If I had, for instance, 1 over x plus 3, and I had g of x as square root of x minus 4, let's see if you can tell me what f plus g of x would be, factoring in the common denominator. In other words, you can just write this plus that, but then you actually have to add them and find the common denominator. Let's see if you can do it. That's just yesterday's stuff. And the new stuff is to find the domain of the answer. All right, so one step at a time. Here's f of x. Here's g of x. You can add those together if you find a common denominator and get the answer. I'll pause while you give that a shot. All right, so you should have said that this had a denominator of 1. And then you should have said, all right, to get them to have a common denominator, you multiply the denominator. Right? So then I'm going to multiply 1 times this, which do I really even need to multiply by 1 on the top and the bottom? It doesn't really do anything. But over here, I'm definitely going to need to multiply by x plus 3 and x plus 3 like that. Now, some people have asked me before, why don't you just multiply both sides of this equation by x plus 3? It's not an equation. You can't do that. You got to multiply by x plus 3 on the top and the bottom. Okay. Now, because that's like multiplying by 1, right? We haven't really changed our problem. We just changed how it looks, so it's got a different denominator. So now, final answer has a denominator of x plus 3, and on top we have 1 plus. You can't even actually multiply these together. If you thought you could FOIL that out, you can't. So final answer is just to leave it that way. Square root of x minus 4 times x plus 3. There you go. Kind of complicated, but that's your answer to f plus g of x. Oh, maybe caught a little mistake there, Mr. F. Oh, can you cancel? Well, that's a good question. It feels very tempting to cancel those, but you cannot. Can anybody tell me why? Yes, sir. If the entire top is a multiplication. So in other words, if this had been a multiplication right there, then you could have canceled those. But you can't because this is part of an add problem. I know this right here is the times. I get that. That's not good enough. You still can't cancel those. So, good question. Glad you asked. Hold on. Undo that move. And get that out of there. And that out of there. Okay. So, how about this domain? The domain of this, it's really tempting to look at this right here and try to find the domain by looking at this guy and saying, okay, let's set the denominator not equal to 0. Let's set the square root parts greater than or equal. You can't do that. When you have a new function that's made up of two parent functions, you have to go back to the original one's domain and range. This is like the child, and these are like the parent functions. They produced this child, and their domains are what's going to set the child's domain. Here's why. Let's say that I wanted to stick in a number like -3. Do you get, as you're computing this in the middle of it, you were going to stick in a -3 into this function and it would kill that function. Even if it doesn't kill the answer, which it would in this case, even if it doesn't kill the child, -3 would have killed the parent in the first place. So, bottom line, I know this is hard to understand, but you have to trust that you cannot look. I could show you, it'd take me 20 minutes, and we don't have time for that. I could prove it to you, but you can't do the domain on this by just looking at this. Here's the main reason. Remember how you guys kind of wanted to cancel this off? That does happen sometimes. This one wouldn't work, but if this canceled off, do you get we'd never even know that -3 was an issue? By looking at the child function, we'd say, well, nothing canceled or nothing crashes this, so it's all good. Because things canceled that would have caused a problem, but they canceled. So you have to look at the parent functions, because even if something like that had canceled, a -3 would have killed this parent function, and therefore the child function has to factor in the parent domains. So long story short, what's the domain on this guy? Can't be -3. What's the domain on this guy? Has to be, you set the under root greater than or equal to 0. So x has to be greater than or equal to 4. So here's 4, and it has to be greater than or equal to that. Those are the two parent domains. So to get the child domain, you have to say, where do these both overlap? And right in there is where they both overlap. And so this guy's domain is where they overlap. X is greater than or equal to 4 is the domain of this one. And I know you can look at the child function and say, you know what, I could have done this a different way. Yep. And you also, oftentimes, if you just check the domain of this and do it that way, it'll often work, but sometimes it doesn't. So I'm going to have to see that you went back and checked the two parent domains and saw where they overlapped to get the child's domain. I gave this somewhat morbid example in the other class, and I think it actually helps you understand it a little bit. These are susceptible. These are things that they're like susceptible to, that they can pass down to their child. And this is, for instance, anything that's lower than 4 is a problem for it. So it's going to be a problem for the child. For instance, when I go in the doctor says, tell me about your parents. Your parents are both gone. Okay, so what did they die from? Because whatever they died from, there's a chance that I will die from that. That's why he's asking me that. Now, of course, if they were hit by a car, is that likely that I'm going to get hit by a car and die from that? No. But if it's cancer, sad to say, runs in families. Okay, if it's heart attacks, also runs in families. So that's something that you gotta, like, if you get a family history, the parents can, their weaknesses can go down to the children. Again, not in everything. There's certain things that, like my dad, for instance, was allergic to broccoli or something like that. I'm not allergic to broccoli. None of the other kids are allergic to broccoli. So it's just, he had it, but nobody else does. But there are other things that do tightly follow down through family lines. Okay, so it's kind of like that. You can't just ask this child what he's allergic to. You got it, because the way these work is the number that's going to go in, it's going to go into both of these functions first before it ends up coming out like this. So you got to check the parents, not just the child. Okay, so let's give you another one like that. Let's say it's f of x equals 1 over x minus 2, and g of x is going to be the square root of x plus 1. Would you please figure out what, let's do f times g of x, figure that out, and then figure out its domain, which will, of course, depend on the two parents' domains. And pause for a second while you work on that one. Okay. So, what do you think? This guy's domain, everything except 2. Agree? Okay, good. This guy, the under root, greater than or equal to 0, x greater than or equal to -1. Here's -1. It's got to be greater than or equal to that. Now, those don't match up real nicely, but there are some places where they overlap. That's what you're looking for. Remember, like, overlap is actually intersect. Okay, so we're looking for the intersection of those two domains. So, where do they overlap? They overlap when things are bigger than 2, they all work, right? How about between -1 and up until 2? Did you catch that also works? They're both shaded in between -1 and 2. But this one isn't shaded after that, so we can't keep going, further to the left. So final answer is, I'm going to put it on a number line because I like number lines best. And I'm going to say 2, it can't be. And -1, sorry, it can be. And it can be in here. And it can be in there. There is the domain of this child function right there. Raise your hand if you had that right. Awesome. Then f times g of x was to multiply them. 1 over x minus 2 times by root x plus 1. Do you get that I can times things or multiply things without having a common denominator? I don't need a common denominator, so I'm just going to times them. Times across the top, times across the bottom. Square root of x plus 1 over x minus 2. If you can factor it, you should, but you can't. So you don't. And therefore, nothing cancels. Sir? All right. If you want to write the domain in a different notation, first of all, you're taking your life into your hands. Because if you've already got it this way, and then you screw up in writing it the next way, like I just did right there, I made 2 mistakes on purpose. See how it can be dangerous to take something that's already done and right and try to rewrite it? Because now I've wrote a wrong answer. What were the 2 things I did wrong? Yes, sir? Bracket on this and union symbol in between. But yes, I'm okay with either. But if number lines work well for you on this type of problem, I think they're the best. Especially when you're trying to see things that overlap. Try overlapping that with this. You get what I'm saying? That overlapping those is going to be a real pain. You can do it, but if you see it with a number line and you just go, oh, see, they're both shaded. It's so much easier when it's visual as opposed to just symbolic. Some of you are symbol freaks and you like that kind of thing. Fine, no problem. But you can do the whole thing with interval notation if you want. I'm just telling you, I think that number lines make it the easiest for you. All right, now there's one more twist that I have to add in. And by the way, I haven't even taught you the new stuff. That's why I'm not going on and trying to teach the new stuff that we could have done today also. The new stuff is not too tough if we can get you good at the stuff that we're doing right now. All right, for adding, subtracting, and multiplying, you'd get the same exact answer. This was the domain, right? This was the domain for this. If this had been f plus g of x, same exact domain. No reason to recalculate it. It's the same exact thing. You just overlap the 2 parents. And for f minus g, domain, same exact thing. No reason to recalculate it. So what's the one I'm leaving off? Divide. If it's f divided by g, then there's an extra complicating factor. Let me show you why. F over g of x, what makes a difference? You're dividing by a function. We're dividing by g. Go back to g here. Do you get that it's okay normally if g equals 0? Like if I stick in a -1, that doesn't actually cause a problem because it's the square root of 0, which is equal to 0. That's not a problem normally. Why is it a problem on this? Because if g equals 0, then you've got a 0 in the bottom of a fraction, and it's going to crash the parent, or sorry, it's going to crash the child function. So whenever you're dividing, you have to add in a 3rd number line to overlap. And that's going up here. And that's that the denominator here, g of x cannot equal 0. this number line's only job. It's not like a combination. It's just asking this. What would make g of x equal to 0? And what's the answer? What would make this function equal 0? -1. So -1, which is right here, which was okay up till now. See it in the answer? It was okay. But now we know -1 was normally okay. It's not okay because it's going to make g equal 0. And if it makes g equal 0, then this whole thing will crash. So you need a third number line added in, and then you see where they all overlap. Do you get the only difference is going to be actually at -1 right here? And now I'll say, ooh, I guess it can't be -1. And where it overlaps shifts over a little bit. And it can't be -1 anymore. I'll just get this out of here. Hold on. Now it's got to stay in here. And it can't be -1 anymore. Even though it works down here, it doesn't work for that. So now this needs to be an empty circle if this was a divide problem. Okay, so what's the complicated one? Divide. How many number lines do you need for that? 3. The two parent ones plus the bottom function, what? What about the bottom function? Can't be 0. That's the third number line. All right. So I'm going to give you one problem like that where you do start to finish with what is f divided by g. We'll do just like that. Where f of x is going to be, I'm going to keep it simple here. 2x minus 5. Actually, that's g. G of x, 2x minus 5. To get normally, it's not a problem if that's equal to 0, but it's going to be a problem this time. Actually, I'm sorry, I'm going to cheat just a little bit and make it a 6, because then I get a nice, easy answer to what that is, what would cause it to be 0. So that's g of x. F of x is going to be 1 over x. So figure out what f over g of x is equal to, and then give its domain, which will involve 3 number lines if you do it right. I'm going to move these over a little bit so that I have room to put my number lines all on top of each other, all 3 number lines, and see where they all overlap. I'm going to pause while you give that a shot. Okay, let's see how you did. Everything except 0. What crashes is, no, actually the domain question is not what crashes it, it's what can I feed this? All real numbers, everything, good. Why can't that one crash? Because I don't care if it equals 0, it's just, can it turn into a square root of a negative? No. Can it have a 0 on the bottom of its denominator? No, and therefore you can't crash that one. All right. If I was doing add, subtract, or multiply, I would be done right now. I would be overlapping these guys just like this, but I'm not because this is a divide question. So I need to add in this third number line, which is, can you make g be 0? G, we do not want, g of x, we do not want it to be 0. Is there a way to make g of x 0? Yeah. And again, it's not x equaling 0, it's x equaling what? 3. X equaling 3 would cause g of x to be 0. So 3 is a problem. Why? Because 3 would make the function 0, and the 0 can't be there. Therefore, 3 is not allowed. So now I got to see, where else is it allowed? Everywhere else. this number line is only about what makes g of x not equal to 0. Now, last thing is, I see where they all overlap. They all overlap after 3. They all overlap between 0 and 3. And they all overlap when it's smaller than 0. So there's the 3 zones. I'm going to put it on a number line. Hold on. Can't be 3. Can't be 0. It can be anything other than that. So there it is in number line form. If you want to make it interval form, you'd say negative infinity to 0 with parentheses, union, parentheses, 0 to 3, parentheses, union, 3 to infinity, parentheses. Okay. How many of you got that one right? All right. If you didn't, do you have follow-up questions like, I don't get this part or that part? You have to ask me. I can try to explain. Yes? Good question. All right, let's actually figure out what this function is. Notice, I didn't even ever find out what this function was. And I found its domain. Because you look at the parents to figure out the domain. So I'm going to go now and figure out what is f over g of x. It is 1 over x over 2x minus 6. Then I'm going to flip and multiply this. I'm going to put that over 1. And I'm going to change it to times by, flip it, 1 over 2x minus 6. There, I'm just flipped and multiplied. So now it's that times that. So now it's 1 times 1 on the top is 1 over x times 2x is 2x squared. And x times negative 6 is negative 6x. But the thing is, I know you could try to go and find this guy's domain that way, but you can't trust it. I know when you factor that on the bottom, you will get 0 and 3. True. But you can't trust it. Why? Because any moment in here, something could have canceled that would have lost you that information. Like, can you imagine that if this had been like reversed and this was on the top instead of the bottom, and then I could factor out like an x, for instance? I can't in this case, but if I could, then that x could cancel, and all of a sudden I'd lose the fact that 0 is not allowed. So you can't look at the child to get its domain. And yet many of you will on the test. You'll forget this. You'll just say, oh, I looked at the child domain. We're going to purposely, on purpose, make sure that if you do it that way, the answer doesn't work. You've got to look at the parents because there's often something that cancels along the way. Yes, sir? I know what you're saying, and I know if I factor this thing, it'll be x and then 2x minus 6, and I know you can get 0 and 3. I'm not disputing that. What I'm saying is, had this function canceled anything along the way, which it didn't, nothing canceled. If anything had canceled, then you wouldn't have noticed. Like, let's say this had canceled off. You would have thought, oh, so this everything works except 3. But you would have not noticed that 0 also canceled off along the way, and that's why it's not safe to trust looking at the child function to try to get its domain. You got to look at the two parents to get the domain. All right, so enough about that. Now let's turn to one last thing. Your homework for tonight then, let's go through it real quick here, is to go to the first page and go back and do the domains on the first page. The first page of your homework was kind of a fade from blue to orange. You see that page? All right. On that page, you're going to do the domains now. Never doing ranges, just the domains. Next page, is the next page the one where you found, thank you, let me look. The next page is yellow. And on the next page, we also do domains. So everybody do domains on the next page, the yellow page. The next page is kind of a purpley color page. That is not about having two parent functions, right? That's about finding that difference quotient thing. You do not need to do anything different on that page. That's done already, I hope, as long as you did it. And then the last page is this, the next page is the orange page. We're still skipping the orange page. but we are doing the gray page. All right, so for the gray page, it says problem 51. I want to show you that one real quick. I'm going to pause for a second while I pull that up. All right, so here's 51. They ask you for f plus g of -3. The problem is, if I just knew what the f function was and the g function was, I would just add them together, and then I'd stick a -3 in the function. But this is really weird. I guess it's a function. It doesn't break the rules of being a function, so it's a function. How am I supposed to do this? Well, I wish they would have given you a lead-up question. What if they first had asked you what f of -3 was? Look at that. What's f of -3? 4. See why? It's like saying, if x is -3, this is where x goes, right? If x is -3, what is y? That's what this is saying. The answer is 4. Then, what do you think my next follow-up question would have been? What is g of -3? Exactly. Let's go down here. What is g of -3 equal to? -2. Now that you know what f of it is and g of it is, what do you think f plus g of it is? Well, what was f of -3? 4. What was g of -3? What do you think you're going to do to them? Add them. 4 plus -2. And the answer is 2. All right, there's a couple in there that'll stretch you, and I want to warn you, I know many of you are going to look at the key, and there's nothing wrong with that, but the key has a mistake on problem 55. You might want to note that somewhere. Problem 55, the answer is supposed to actually be +3 on number 55. Okay. Can you imagine right now is when I would start the new material? It wouldn't have been good. All right, so I'm glad we had a day to kind of catch up here, and I feel like you're in a good place with this stuff. But I need you to be in a good place with this stuff, because when we go on to new stuff tomorrow, it's of course based on understanding the stuff we did today. So that's all I got for you for today.